So today I'm going to be modifying this Arduino shield. It's a motor shield. It uses these L293 chips here and here as the stock chip for this module, but these chips in particular will only support 600 milliamps apiece, or about 0.6 amps. I intend to be using a fair amount more power than that, and I need to upgrade. As you can see here, I have ordered from Mouser the 7544 chip, as seen here, and I have also ordered the heat sinks. I will be using 2 of the chips and double stacking them in combination with a heat sink in an attempt to get myself the maximum amount of power I can extract from this. So we're going to go ahead and set that up and then substitute it in. The first thing I need to do is take a little standard heatsink compound and apply a very thin layer to the top of the chip. I will also be applying a very thin layer to the bottom of the chip. We don't need much. Once I have done that, then I can take the clip-on heatsink and apply it to the chip. Now, one thing to notice, and I'm not sure if you can see it that well, there is an indentation at the end of the chip that is critical to determine which way this is oriented. You need to keep track of that. For this case, I have decided that the indentation will be opposite this little notch in the heatsink. That will allow me to keep it straight for later when I need to install this. So I just simply place the clip on it, bend it a little bit to get it on there, and it snaps into place. Nice, neat, and easy. Now if I was using a single chip, at this point I would be done. However, I'm going to be using a dual chip, so I will take a second chip, apply a little bit of heatsink to just the top surface of this one. It doesn't really need much. And once again, I need to make sure that I orient things correctly. So I've decided that the notch will be going to this end. So I will set this on top, like so, very, very neatly, and line up the legs. Now, the legs aren't quite touching, so I'm going to remove this and ever so gently just squeeze the legs in to try to get a little bit of pressure on them. Not much. Certainly don't want to overdo it. And I replace the chip, once again checking to make sure it's properly oriented. And this time the pressure, this time the pressure wants to hold it in. Much better than it did before. So now I can line up the individual legs, and I will take the soldering iron, it's just a dab of solder on it, and that is not a very good solder, but doing one on this corner, I will quickly do another here. Will prevent it from moving around while I work on it. Now I can place it down and attach each pin with a tiny little bit of solder. As you can see, I've accidentally joined the two together. Not a good condition there. So I'm going to remove a little bit of the solder with solder wick. And you can see that they're now separated. I'm going to go back through, check each one to make sure that I've got a good solid connection. Maybe touch up as necessary. Alright, then I can flip it over, repeat the same thing on the opposite side. That side actually looks a fair amount better. So now I have two chips, as you can see, connected on a single heatsink, which is actually working quite well because it's hard to hold on to here. Now if I look at the original chips on the motor shield, this can be removed. Oh, so gently. And once again, we want to notice that this indentation knot is here, and have a look to make sure that I've got it correctly oriented, and I decided that was opposite, so that is this end. And I can place this new chip gently and carefully. And with the chip seated, you can see that we now have a double chip with a single heatsink on one side. And now I'll just have to repeat that for the other side. And we will have this Arduino motor driver running at twice the value for a given replacement chip. The new chips are 1 amp continuous use and 2 amp surge. So I should now go from 0.6 amps in the original configuration to 2 amps continuous and 4 amp surge.